Alright, problem reads, which structures would be classified as aromatic? 1, 2, and 3 here. So for aromatic, this implies planar is one requirement, cyclic, conjugated, right? And Huckel's rule, odd number of pi bonds, aka 4n plus 2 pi electrons. That's Huckel's rule, right? So, well, all three of these are cyclic, right? So, for the problem, they give no information as to planar. They all look planar. I would say they give you no information, so assume we can't distinguish them. We can't distinguish between the three of them based on planarity. So I would say I would give them all a pass on that one, basically. Conjugated, right. So, well, this one right here, we can check off with that, right? We can see that by our eye. Now, can we show that, well, let's see, 1 is conjugated, right? So, if we go here, right, we can draw this as a resonance. Might be getting in the way, so I'll go around here. We could draw this as a resonance like this, right? So that ended up right here, right? So that's resonance. So that shows conjugated system, right? And same here, right? We could go here and here. And so what would that look like if we pushed all our arrows in a reasonable manner? So do we come out with something that looks okay? That's still conjugated. Let's see. We moved this down here. So we just shifted our plus charges 1 over, right? So you can see that it's conjugated, right? It has resonance. We can move every single pi bond with resonance, electron delocalization, okay? So all of these guys are conjugated, okay? So now how many pi bonds, or I should say pi pairs of electrons count too, right? So this guy, right, is a pi pair of electrons, or you might just want to. It's easier for me to think of this as one, right? One pair of electrons, right? This is a pair of pi electrons there. Or you can use, right, the integer rule. But, right, we got 1, 2, 3 here. We got 1, 2, 3, 4, 5, 6, 7. We got 1, 2, 3 here, right? So they all have odd number of pi pairs of pi electron pairs, I should say. Probably the most appropriate way to call it. So that's A. Okay.